In this video, we will import a CAD file into SLB and use it to quickly and accurately create a structural model. All concepts discussed in this video are also applicable to RCB and PTD. CAD importing in RCB will be shown in subsequent videos. An architectural CAD file has been stripped down just to the information that is needed to create the structural model in SLB. Each of the structural elements that will be imported have been drawn into their own separate layers. So for example, the columns in one layer, walls in another layer, and geometry lines in their own layer as well. In this particular case, I've drawn the floor outline in its own separate layer. The floor outline is best drawn as a single closed-form polyline wrapping around the entire perimeter of the slab. This is done so that when the mesh is generated, it is generated properly and generated within the entire slab area. Again, it's not entirely necessary to draw it into its own layer, but just makes it a little bit simpler when importing in the SLB software. Polylines and line elements are used to define areas that will have different thicknesses, such as the folds in the slab, the set downs in the wet areas, and areas that will have no thickness, such as the voids. In this case, we also use line elements to define areas that will have different loading. For example, this corner of the slab will have a larger planter load. So we define that area using a line element. Columns have a single closed-form polyline drawn around their perimeter so that they can import correctly. And the program will automatically pick up the shape of the column and the angle, so be it rectangular, circular, or complex. Similarly, walls are drawn with a single closed-form polyline wrapping around its entire perimeter. Even for walls such as the shear core, we draw one polyline wrapping around its perimeter. In this case, the software will use the two parallel lines running along the wall's length to determine the wall's length and thickness. Alternatively, I could have drawn a single line through the center line of the wall, and the software could use that line to import the wall. Going to the SLB software, we'll quickly review the CAD Import settings before we import the CAD file. The CAD Import settings are under the Settings tab and CAD. Typically the units in a CAD file are in millimeters. The units used in the INDUCTA software are meters, kilonewtons, and megapascals. Therefore, the default scaling factor of 0.001 will be okay. At the time this video was recorded, CAD files up to AutoCAD 2018 or equivalent can be imported into the INDUCTA software. CAD files are imported via the Home tab and pressing the CAD bitmap button. To load the CAD file, we navigate to CAD, Load, and select the file that we want to import. With the CAD file loaded, if we try selecting it, we see that initially we can't select the CAD background. This is because by default the structure will only select structural elements, which we currently don't have any modeled. To be able to select the background CAD image, we have to switch on Import from CAD. So this particular CAD file was not rotated in AutoCAD, so we'll do that now quickly in SLB just to make the model easier to work with. So with Import from CAD on, we select a line that we want to rotate. We go to CAD, Shift, Rotate, and select Option 1 to rotate it to the horizontal. With the CAD file imported, we'll now start importing the various structural elements from the CAD file. The various layers that were drawn in the DWG file are visible under the Layers drop-down box. So we'll go ahead and select the floor outline layer. With Import from CAD on, we drag and drop to net select this layer, and then press Slab or Geometry Line to import this geometry line. Switching off CAD, we can select what we've just imported a geometry line wrapping around the entire perimeter of the slab. Switching CAD back on, we repeat the same process for the other geometry lines. So the lines that will be defining our areas of different thickness and loading. So import from CAD on, net select, drag and drop, and press slab or geometry line again. Now for the columns and walls, we'll import them in a slightly different manner. So rather than navigating through and selecting the individual layer, we will isolate the layer in the working area. So how we do this, we switch on all layers, have import from CAD on, select the particular layer we want to isolate, right click, and show selected shape layer. So this automatically goes to the columns below layer that we drew in AutoCAD. So with import from CAD on, we net select to drag and drop, and press column to import all of the columns. And we repeat the same process for the walls. For the walls, we choose the parallel lines option and not the center line option because we didn't draw a center line through the center of the wall in AutoCAD. With all of our various elements imported, we switch off the CAD visibility and we can see what's come in. So the various geometry lines that will be defining our slab zones, so the areas of different thicknesses, areas of different loading in this case, our walls, and our columns. Now if we try to select inside the slab zone itself, we're unable to. Now this is because the slab zone and its thickness has not yet been generated. How we generate the slab zone is we run the mesh. So this is done under the Home tab or under Solve Mesh. Now the program will automatically generate Find an Element Mesh based on some predefined rules. Now all of these rules will be covered in more detail in another video. We can see triangular mesh automatically generated in our slab zone. We also see a few red dots. Now these red dots indicate a closed node error has occurred at this location. If we zoom into one particular area, we can see exactly what a closed node error is. Based on the software's predefined meshing rules, it has attempted to generate Find Element Mesh to the column center in this case and along the geometry line, but was not able to without creating a very small element. So what this means is that the results at this particular location won't be accurate. Now ideally we should clean up these meshing errors before we continue. Now before we start modifying the model and cleaning up meshing errors, let's talk about accuracy. You may have noticed in the previous window when we meshed there was a warning about the accuracy of the structural model. If we zoom out and press redraw to clear the mesh and start selecting various structural elements, we can see that a high degree of accuracy is coming from the AutoCAD file. So the default units were 1 millimeter. We can see that that level of accuracy has been brought into our structural model. So this level of accuracy may be needed to generate a structural drawing or an architectural drawing, for example, but it's not needed to capture the structure's behavior, to capture its structural response. It also makes the model much more difficult to edit and basically makes it sensitive to meshing errors. So it's generally a bad idea to use this high level of accuracy in any Find an Element software. So before we continue, the very first thing that we'll do is we'll round off the geometry. So rounding off to 1 or 2 decimal places is recommended, and if new to the software, rounding off to 1 decimal place or to the nearest 100 millimeters is recommended. How we do this, we go to Tools, Round Off, make sure that we have nothing selected, meaning that it will round off the entire job. We go Round Off and select 1 decimal place or 100 millimeters. we see the model shift slightly, and if we select the various elements now, everything has been rounded off to the nearest decimal place. So the benefits now are that the model is much simpler to work with, meshing errors may have been cleaned up, or they will be easy to clean up, and the model is less sensitive to analysis errors. If we generate the finite element mesh again, we'll see what's happened. So we can see we've cleaned up, by rounding off, the meshing error that was occurring in this area. The meshing error at the column still occurs, so we'll have to do some manual cleaning up in this zone. But we've also introduced another meshing error here at the planter location. Now we'll zoom into this area and have a look as to why that happened. Before we zoom in, we'll press escape to redraw. So escape is just the shortcut for redraw, to clear the mesh visually off screen. Note that we don't actually delete the mesh when we do this, we just clear it so that we don't see it. If we want to see it again, we can press Show Mesh on and off in the View tab here. Pressing escape to clear again. And we'll quickly just try to select some of the flooded areas that were created by the geometry lines that we defined. So we can see all of these flooded areas that we'll be assigning different thicknesses to have been created nicely, but something funny is going on here at the planter area, so the area where we have this closed node error. So we can't select these separate areas, meaning that the flooded areas haven't been created correctly. Now, zooming into this area, zoom right in, we can see the flooded area isn't created because there's a small gap between the perimeter edge geometry line and this internal geometry line defining the planter. If we select the planter line and have a look at its properties, we can see that the rounding off process caused some information to be lost. So the diagonal edge line defined by these 2 points and this particular line, basically we've lost some information via the rounding off process. So one option to fix this would be to get it back to the exact intersect location again by using the Extend with Mouse and Clip tool. How we do this, we select the line we want to extend and clip, hover over its node, right click, extend with mouse and clip, drag across the intersection line, and left click again. So if we select the line, we can see that now the intersect point is exact. However, we've introduced a high degree of accuracy into the model again, which we may not necessarily want. So if we choose to keep it like this, we just have to keep this in the back of our mind, that if we were to round off again, we would lose this information. Now, we don't want to have to repeat work, we don't want to have to fix this area again, so probably an easier option would be to insert a node on this perimeter line. So we will undo to undo the last operation. So that's gone back to its previous coordinates. And we will insert a node on the perimeter geometry line. So how we do that, select the perimeter geometry line, right click, insert a node. So this has put a new node in exactly where the mouse cursor was. Double check our snap settings. So we go to the Home tab, change our snap settings to snap to corner, select the perimeter geometry line, select the node that we just inserted, drag and drop it to the coordinates of the geometry line defining the planter area. So its coordinates now were unchanged and at 1 decimal place degree of accuracy. And this new geometry line node that we've introduced is also now snapped to that exact coordinate with the desirable level of accuracy. So we fixed this side, now we just have to fix this edge. So holding the middle mouse button to pan across, we'll zoom into this area. So we can see that the planted geometry line via the rounding off process overshot the perimeter line. So one undesirable option in this case would be to select the perimeter geometry line, right click and insert intersection node, right click, insert intersection node. And if we look at the coordinates, we see that a node has been created at that exact intersection. Again, undesirable in this case because it has a high degree of accuracy. So pressing undo, or the shortcut Ctrl-Z to get rid of that node, we'll perform the same operation that we did in this left area, but this time we will use a new tool, Pull to Node, and we'll also use a few shortcuts. So to insert a node on the perimeter geometry line, I'll use the shortcut Ctrl+. So select the line, press Ctrl+. That inserts a node at the cursor location. Now I will go to the node that I want to pull to, or the master node. I right click it, set Pull to Node. So this red circle now indicates that this node is a master. I will now create a net selection area. So anything in this net select area will be pulled to the master node. Pressing enter pulls the new node that we generated to the master node. Pressing escape to redraw, we can select the perimeter geometry line, pressing in its properties and pressing the arrow keys to navigate to the node that we want to look at. We can see the coordinates now have 1 decimal place accuracy. And similarly here, the coordinates are at 100 mil accuracy, which is what we wanted. So we fixed up any potential meshing errors in this area. We've created our flooded areas correctly, which we can't select yet, we don't have any mesh, but this area should now be fixed. Now going back to this particular area where we had a meshing error at the column, we'll fix this area up as well. Now, because we edited the model, we've lost our finite element mesh, so pressing inside the various flooded areas doesn't select anything. But we don't have to mesh the slab again to see where our errors were. So pressing Shift-E on the keyboard, the shortcut to show the mesh, we warn there is no mesh. However, the program still will show the red dots where the meshing errors were. So this way we don't have to remesh every time we make a small change. Now I'll perform all of the previous operations again, but this time using only the shortcuts for the various tools. So we select the geometry line that we want to insert a node on, hit Ctrl+ on the keyboard to insert a node, select the column that we want to pull this new node to, press Ctrl-Shift-Down, so down being the down arrow key, net select, and hit enter. Press escape to redraw, and navigating with our cursor to see the new node that was generated, we can see it's got 1 decimal place accuracy, which also matches the column coordinates. Zooming extents and meshing again, we should see that there are no meshing errors now. So no errors in any of those locations. Pressing escape to redraw just to clear the mesh visibility, we can see that our flooded areas are now created correctly. So with the mesh generated, we can now start inputting our thicknesses and loading. Now, inputting thicknesses and loading will be covered in more detail in other videos. So we'll just stop that there. Now, let's imagine that the design has progressed. So we've moved on from the preliminary stage. There's been some architectural changes to the model. We want to input these architectural changes into our existing structural model, our existing SLB model, and see what effect they have on our design. So before we input these changes, we need to set a reference point in the existing model so that we can align the new CAD files to it. So to do that, we must switch on the CAD file, show all layers, and go to CAD Reference Point and Set. So with the CAD drawing loaded, we have one additional snap setting, which is Snap to CAD. So if we zoom right in, we'll select a common point. Typically, if we're in RCB, this should be something that runs up the full height of the building. Generally, the shear core is a good idea. So we can see that we now have a reference point set on the outside face of the shear core. Now, we must unload the existing CAD file, the existing CAD background. So we go to CAD, Unload, and we clear the current background. Our reference point is still there. To load the new CAD file in, we go to CAD, Load, and we'll select the updated file. And we can see it's slightly shifted because the coordinates didn't match the existing drawing. To align it to the existing reference point, we go to CAD, Reference Point, and Match. Making sure Snap to CAD is on, we select the same point. And we press Escape to redraw. So a visual inspection shows that pretty much everything is the same, except that these columns have been moved and the size of the planter here has been reduced as well. So we'll get rid of the columns that we basically have to get rid of, have to delete, that have changed. So import from CAD off. Press and hold Shift to select multiple elements, and we press delete. Switch import from CAD on. Again, we don't have to isolate the layers just because it's a few local elements. Just net select and press column. Now switching the CAD file off and selecting the elements that we've imported, we can see that again they've come in with a high degree of accuracy. So all of our previous elements still have that 1 decimal place 100 mil accuracy that we desire for our structural analysis. So we just want to get these columns to the same degree of accuracy as the rest of the model. Now, rather than rounding off the entire model, we'll just select these individual columns, go to Tools, Round Off, and hit 1 decimal place. So everything is now that we've selected rounded off to the 1 decimal place. Switching our CAD back on and zooming into the planter area, rather than re-importing this line, we will essentially trace over this new CAD image. So we don't have to import anything, we'll just be moving this existing geometry line to match the CAD file. So Snap to CAD on, we drag and drop this down to the new coordinates of this planter. So switching CAD off, selecting the new element, we can see there's the modified element, we can see there's a high degree of accuracy. Again, we just round off this element by itself by going to Tools, Round Off 1 decimal place, hit OK, and we just have to move this new node, pressing F2 to change the snap settings, and drop it to this new location. So zooming extents, meshing again. We've quickly imported all of the architectural changes and then locally rounded off the elements that were changed to our desired level of accuracy of 100 mil. Now, a brief summary of what we learnt in this video. We learnt how to clean up CAD files so that they import smoothly and quickly into the INDUCTA software. We learnt what meshing errors were and how we clean them up, and we talked about accuracy and what a suitable level of accuracy is for our structural model. Now, it should be noted that this essentially was an idealized case, a best case scenario where the CAD file was cleaned up in a very nice manner that made it easy to import. Now, it will often be the case where we are unable to import CAD files that are cleaned up so nicely, hence we will get many more meshing errors. Or the geometry will be much more complex, which in itself will cause meshing errors. And some of the editing tools that we touched upon today, we'll have to use them a lot more, or use some different editing tools to clean these meshing errors up. Now, cleaning up of meshing errors will be the topic of the next videos. Thank you for watching.